All right, so we're on to problem 3 here of the December 2023 bronze contest. This was a tough problem. It takes a while to kind of figure out what it's asking, and then figuring out the algorithm to solve it is also difficult. Um, I'm coming at this presentation here from the point of view of someone using Python to attempt to pass the bronze division. Um, and really, to do that here, the uh, it's not necessary to get all of the test cases correct to do a full solve of the problem. So I'm going to kind of coach through a solution here that got 9 of the 13, which is, again, kind of good enough for a passing score, assuming the other problems were full solve, which those other problems were quite a bit easier. Um, so, uh, you know, encourage students to not get hung up on being perfect as much as um, making progress here. So, um, a couple, okay, so coming at it, what are the problem solving insights here? The thing that is key is that the heights are all different because they're distinct integers. Um, so, um, that's going to be kind of one of the key insights here. But the other thing is that sometimes we end up with something that starts off already correct. So in this example, that was one. Um, but we're going to need a algorithm to tell us if the current position is valid. And so I want to start there and kind of talk through that part. Um, I came up with this algorithm is valid. The solution in the official solution used Python and did some, where is it? For loops with sums. I didn't know how to do that. I don't usually use Python myself, so wanted to kind of go through what are the common tools here that students know. Those are usually arrays and maps or dictionaries. So just sorted the initial array of heights and created a hash map where we're going to map from the value to how many values are larger than that. Um, so the first time it encounters that number, it'll tell you how many more till the end. And if you encounter that number again, you're just kind of overriding that value. And then you should be able to just loop through and compare that to what the target should be. And return false if it encounters something that's not valid, or return true if it makes it through all of them. So that's, again, probably not optimal, but again, for bronze, and should be able to get most of the points possible here. The next thing, I guess, the next problem-solving insight is that there is kind of a special, or really we need to figure out when it's not possible to provide the answer. So how to do that? I kind of made an assumption here in my code to try to just think about the largest possible number. So the largest possible number would be the one that has a value 0. So essentially, we need to get this to be the largest using these growth rates. And is that possible? And so why did I just worry about the largest number? because wanted to simplify things, first of all. And then uh, we're going to end up checking a lot of values anyway. So I wanted to check, is it possible there? But then really just run through a bunch of potential values, kind of the guess and check method, and use that is valid function. So I didn't want to, do that. We could just do that, for um, every value from here, but wanted to skip that if possible, and just realize, okay, it's not going to be valid for this. So created a function check max that looks for the zero, and when it finds it, checks every other value. Make sure that if it is shorter, that the growth rate is bigger. And if the growth rate is bigger, using just a little algebra to figure out, okay, where will those two lines intersect, or what value will that be? And then really just taking that as minimum value, and then doing a guess and check. Again, not using any fancy Python syntax to make the arrays, but just kind of going through and adding a new value for each one, running that through the is valid. And if we get to doing it 1,000 times and haven't found anything that's valid, just assuming that one is not valid. So it's a -1. This, again, isn't perfect. It's not going to be a full solve. There might be some test cases where the range will be greater than 1,000, because we're really just looking at the maximum value. But this was a kind of quick way to get enough of the points possible, enough of the points necessary, I should say, to pass bronze. And then I wanted to point out one thing in their contest results, or kind of inputs 4 to 5. It says AI and HI should be under 1,000, which is kind of giving you that bounds of 1,000. It's not too clear because the initial height is HI. It's unclear if they're talking about the initial height should be under 1,000, or the ending height should be under 1,000. But that's kind of where it came up with using 1,000 for in the for loop, and then actually it just using the method of the starting value based on the maximum height value. It actually works for cases 6 through 8. And then even case 9 as well, which is unconstrained. So it ended up working for a lot of them. The full solve, the full points, obviously would be kind of extending what you did here, but for all of the values would be possible. But the I guess the thing to point out, though, for full credit is that it's best to look at just pairs of plants, because they should really, they're all going to be different, and they should all go in order. So you just kind of want to figure out, okay, what are the pairs of plants we should look at, and really run that same idea, same algorithm. Okay, what is the minimum value of steps that's going to be necessary to get that one plant larger than the other? So you can run through all of the pair values in order, and figure out the right minimum for all those. So that's necessary for the full points. I don't think it's quite necessary to do that. So I didn't go through and solve it again. Again, just because the goal was to pass bronze. But the insight there is that you want an intelligent way to not just look at the first value, but to go through all of them and do it in a reasonable amount of time. So instead of just looking at the largest value and making sure every other one is under it, looking at them in pairs, um, uh, and just comparing two for each one. So anyway, that was that problem. Hope you were able to get enough points on it to promote, and we'll see you next time.